Hi guys, welcome to yet another chemistry video. Today we will be exploring the valence bond theory. But wait, what's valence bond theory even? Well, valence bond theory is a theory which describes covalent bonding as the overlap of atomic orbitals from two different atoms. Let's break down some key terms in this definition, namely, what is covalent bonding? What does overlap of atomic orbitals mean? Firstly, covalent bonding is a chemical bond that involves the sharing of electron pairs between atoms to form a stable, shared electron configuration. To better explain this, I will be using an example from the introductory slide. The bonding between two hydrogen atoms, as you can see over here, is considered a covalent bond. Covalent bonding typically occurs between two nonmetals and allows each atom to achieve the equivalent of a full valence shell, allowing for a stable electron configuration. These bonds are directional and can be classified as single, double, or triple, depending on the number of electron pairs shared. Back to the example for the hydrogen atom, each hydrogen atom shares one electron with the other, so both have 2 electrons each and can achieve a stable, fully filled doublet configuration. Okay, now let's break down what overlap of atomic orbitals means. An atomic orbital is a three-dimensional region of space around an atom's nucleus where there is a high probability, more than 90% chance of finding an electron. To better understand what this means, you can check out one of our previous videos in this playlist, which will give you a more in-depth explanation for this concept. This concept is important to understand valence bond theory, so ensure you master it. Anyways, now that we know what are atomic orbitals, how about what it means for them to overlap? Atoms form bonds when their orbitals overlap, primarily because this process leads to a lower potential energy for the overall system, resulting in a more stable arrangement. Hybridization is the concept of mixing atomic orbitals to form new, equivalent hybrid orbitals that are better suited for bonding and explaining molecular geometry. As we saw just now, the electron configuration for carbon only predicts that it can form 2 bonds, yet how is it able to form 4? Hybridization occurs when an atom prepares to bond, creating hybrid orbitals with different energies and shapes from the original atomic orbitals, which allows for stronger covalent bonds through greater overlap. For the case of the carbon atom, it undergoes sp3 hybridization, mixing one ns orbital with 3 np orbitals to form 4 equivalent sp3 orbitals. As the 4 sp3 orbitals contribute to 4 electron domains, hence the carbon atom is able to form 4 bonds, contributing to a tetrahedral shape. This is favored as energy released in the formation of the 4 bonds can compensate for the energy needed to promote an electron from 2s to 2p orbital. And that's about it for valence bond theory and hybridization. Hope you learned something meaningful from this video.